Good afternoon, my name is Kevin Rodriguez. Together with my partner Nixon Sinisterra, we present our poster called Physiology, Effects of Nutrient Deficiency and Stress in Agriculture Crops. Thank you for attention. Graphic abstracts. This graphic shows the main idea of the work. We plants do not have enough nitrogen, phosphorus, or potassium. Their physiology changes very early. Nitrogen reduces photosynthesis. Phosphorus reduces the energy to the plants. Potassium affects water, balance, and root growth. This problem starts before we can see symptoms in the field. Problem-oriented introduction. Nutrition deficiency is a common stress in agriculture. It affects important processes like photosynthesis, plant growth, and root function. Research in maize, sugarcane, tomato, soybean, and bean shows that these deficiencies create interim changes before a yield in reduced, but most study log and only one nutrient or one plant organ. So our objective was to collect and integrate scientific evidence about how plants respond to nitrogen, phosphorus, and potassium deficiency. Bibliograph review methodology. To make this poster, we use for scientific platform Google Scholar, Scopus, ScienceDirect, and ResearchGate. We searched with 7 keywords related of nutrient stress and plant physiology. We reviewed 18 articles and we selected 6 high quality studies. These studies explain how crops respond to nitrogen, phosphorus, and potassium deficits at the physiology level.
Hi everybody, my name is Nixon Sinisterra and I'm going to share the discussions of findings. Common patterns across studies. Nutrient deficiency primarily reduces plant growth and biomass, while photosynthesis decline later varies by genotype and light conditions. All crops adjust biomass allocation as a compensatory strategy, and only few studies examine root architecture or hormonal responses. Specific evidence by nitrogen. Nitrogen deficiency reduces photosynthesis, chlorophyll, and biomass in maize, bean, and sugarcane. Phosphorus deficiency limited CO2 assimilation. Phosphorus metabolic enzymes and leaf area in sugarcane, with tolerant genotypes showing deeper roots. Potassium deficiency restricted growth more than photosynthesis in tomato and soybean, and disrupted hormonal signaling with gibberellin and hasmonium interactions partially restoring root development. Identify knowledge gaps. Few studies integrate leaves, roots, growth, and hormones within the same experiment. Hormonal pathways remain underexplored with limited evidence on gibberellins and hasmonium or AVA interactions. Most studies focus on single nutrients, limited understanding of combined uh, nitrogen, phosphorus, and potassium stress, and field validation of physiological or spectral tools in scarce. Contradictions and nuances. Photosynthesis does not always occur first, as shown in soybean under potassium deficiency where growth collapses before carbon assimilation drops. Nitrogen effects vary with light intensity and maize, limiting transferability in greenhouse results. A strong genotype-specific difference highlights that physiological responses are not universal. Nitrogen, phosphorus, and potassium deficiency recognize plant physiology by simultaneously altering photosynthesis, root, growth, and biomass allocation. Growth-related traits decline earlier than photosynthesis, appearing as the first indicators of stress. Responses are strongly genotype dependent, as observed in beans under nitrogen limitation, sugarcane under phosphorus stress, and tomato and soybean under potassium deficiency. Hormonal interactions and diagnostic tools such as gibberellins and hormone regulations, intermittent and spectroradiometry, nitrogen estimation in sugarcane, enhance the understanding of how crops respond to nutrient stress at a physiological scale. Thank you very much.